So I believe we start. Vadim, welcome everyone. So we have our webinar number 3 out of 5 about functional safety and how we can develop good functional safety compliant products, so to say. And today we have our third series about actually the process that is behind the functional safety products development, and that's what we're gonna cover today. So as let me just figure out if I'm controlling the screen.
Yeah, you are.
I think I am. Yes. So basically, on the agenda of today's presentation, we will have kind of very straight agenda. We'll be talking why do we need a process to be able to develop the functional safety compliant product. Then we'll discuss actually what are the team roles that are required for the typical functional safety project. We will discuss functional safety management plan and V model and why we need those artifacts to be able to actually master the process. Then we'll be discussing the configuration management control and audits because that's kind of the really big part of the life cycle of a typical functional safety project, and not only functional safety project, but also the other ones as well, and the change management as the last part of today's presentation. And the change management is apparently something what we use across the across the life cycle of the project when the active development ends, and then we need to ensure that already let me say this word certified or approved product have to be changed, and then how to ensure that in this part of the product life cycle we are still compliant to the specified standards. So that's our agenda for today. I would like to remind you that we are concluding today webinar number 3 out of 4, or actually 5, we want to do in this series. And I want to remind you that we had during webinar number 1, we had the overall introduction to functional safety, what it is and why we need that and what are the complications. Webinar number 2 was actually about how do we do architecturing in functional safety products. What are the architectural jobs to be solved, and some peculiarities about different architectures that can help us to address functional safety requirements. And today we are going to actually touch this processes part, which is not normally not something what we expect we shall follow. And this is also a little bit, I would say, annoying part of functional safety projects because, well, we have our own processes, we have our own traditions and rituals, how we develop projects and products. And then when we have functional safety blending through the development project, then apparently we have to actually follow a specific process. Otherwise, we cannot later on defend that the development has been done in a correct way. And the webinar number 4 will be a little bit more practical about tools, tricks, and tips for functional safety projects, like what kind of tools we use, how tools can help us to close both architectural tasks and process tasks and stuff like that. And webinar number 5, which we hopefully can fit into the schedule, will be, I would say, a bit more academic about how do we calculate what is the mathematical background of the functional safety, because whenever you screen the standards, you see some calculations, like you have to calculate the diagnostic coverage, you have to calculate and ensure that particular parts of the diagnostic coverage formulas are covered, and that's what we're gonna address in our webinar number 5, if stars gets into the right positions around the solar system. Let me put it this way. So yeah, and today we have, like before, we have me, Alexander Lubimov, who is business director of Actors Development, and Mr. Vadim Dolgopoli, who is our technical solution architect and our functional safety expert, who is extremely tech savvy in terms of how to do functional safety products, and who has been helping a couple of dozens of customers around the globe doing some great functional safety products. So that's our presenters for today. The intro and outro part is on me, where the process part will be done by Vadim, who will definitely guide us through the complications of the functional safety processes. So let's get moving. And the first question that arises in any, I would say, typical development of a product of some kind is why we actually do need a process. So, well, many of us who are developing for many years of different electronic products, we know that without a process, we cannot repeat our previous, I would say, success in creating new products. But in functional safety projects, it's not so much about repetition, but it's about actually using, first of all, some of the best practices that are driven by regulation standards. This is also about demonstrating traceabilities and other evidences that we follow the process that is prescribed by different standards. And also, this is about how we actually do the development from the first try with the minimum of tracking, so to say, and minimum mistakes and minimum problems of making wrong steps, so to say. So in terms of functional safety, the process can be defined as I would say a sequential and planned and controlled set of activities that are required to fulfill functional safety lifecycle objectives. So basically, that's the way we can come up with this definition. And at the same time, this process can, or this sequence of activities can actually demonstrate and help us to meet required safety integrity, meaning that we holistically address all the parts of the requirements, and by doing that, we actually, or doing the steps, we need to have the holistic approach, and that's what dictates, and this is what prescribes the process. So some top level things why the process is needed. Well, first of all, it allows us to minimize systematic failures and common cause failures, because the process defines discipline and structure. So you can actually repeat. This is what I started with. So repetitivity or repeatability of the steps. Then we can actually, I would say, remove the systematic failures from poor design, and actually identify those failures. Then it can actually somewhat make our assumptions that we put into design to be independent, diverse, and validated through the process. So we are not kind of blindfolded by just initial assumptions and just taking them for granted. So we can actually push them on top of the surface by the process. We can actually demonstrate to assessors and stakeholders that we do cautious and I would say correct and understandable way of development. And then, of course, we can demonstrate traceability, something what is ready for audit, and also trustworthy results of our development that are required by the compliance, normally the compliance bodies, towards the typical, I would say, functional safety projects like 61508 and 26262 and stuff like that. So that's why we need a process. That's basically extremely simple justification why the process must be in place. So now I think, Vadimus, it's your part, it's your hardcore part, so I'm welcome to share a microphone with you.
Yeah, thank you very much. Hello, everyone. Let me a little bit scroll back. Yeah, also, if you are doing your product, it does not matter, do you involve safety or not, anyway, you have a process. And this process, it is not necessary to be documented, but in fact, you are using your intuition, you are using your experience to take some steps to avoid errors, and you have this at least in your head. And when we are stepping in functional safety, the standard requires to make this process available for assessor and to demonstrate that steps which we are taking during our development is enough to meet the requirements. And the main philosophy, it is very simple. The right process creates the right products or the right things. So this is the idea. And assessor really does not very interested in your product at all. So their goal is to, or their mission is to see that your process corresponds to the requirements and to check that you follow the defined process. So this is how it should be done. And here process, it is something on top of what you are doing in general product development. And you have to invest you have to invest a lot of effort to create this process transparent and open for assessor and for other parties. So, and this investment allows you to step in a functional safety club. So having this process, next product will be much easier to do because you have experience. You will have at least templates or documents and infrastructure for doing functional safety, and it is what we have to do. Let's and also we are presenting this. We are doing this when we are doing this presentation, we are thinking about how to present this in the best way to understand, and we are not presenting in as it is usually done in classical presentation when we are going into standard like System 158, going through the section by section or activity through the activity. We try to little bit change and make it is not orthodoxal. Let's say we are start from something known from architecture design from previous presentation, and only now touching process to make it more clear and just to have kind of a minimum background and understanding why it is so important. Also, this is the most let's say boring thing in functional safety, because a lot of paperwork, a lot of description and actions, which is we can usually omit in general products. But but unfortunately or fortunately, without these papers, you cannot say that your product is safe. And it is, I would say, even if we look into effort perspective, it takes more time, or at least half of time or effort you need to the normal product. But it is optimistically half, but reality is that your product is only 30%. And if you are only newcomers here, you have to spend 3 times more to be in this club. Okay, how to start your project? So if you are if you need functional safety in your project, you have to start at least from these two documents, which is called Functional Safety Management Plan and Configuration Management Plan. Functional Safety Management Plan establish a process and like, you know, in descriptive way, what you want to do, what's the sequence, what's the actions, what's the output, what's the document you have to produce during entire life cycle to be compliant with functional safety. Configuration management plan answers the question how to store the data, how to put a unique identifier, how to identify your items in your product, and what the sequence should be there. It is one of the part. Another part, it is how to introduce modifications in your design. It is obvious that if you spend a lot of effort, anyway, errors can happen, faults can happen, and we have to answer them systematically, not hidden, but openly discover them and inform your client that you find this and that in this and that cases, and so on. And all of this, how to store, how to handle changes, how to do this, it is established in configuration management plan. And also very important, it is your team here. We'll discuss a little bit later on about the personnel plan and about roles which is needed to cover your need in functional safety design. Yeah, this is, but to start development, you need at least these two documents to start and to move forward with minimum risks that you can omit something. Does not work. Yeah, next slide is about example of table of content for functional safety management plan and for configuration management plan. And just I don't want to go through the items. Anyway, you will get this presentation later on, and you will see in more detail here. Okay, what is inside the FSMP, or Functional Safety Management Plan? This document is described in so we have to distinguish two things here. The first one is activity, what we are doing now, and the document which this activity produces, and also what documents we need to run or to execute this activity. Like, for example, if we're talking about architecture design, the input is safety requirement specification, activity is design in the architecture, and the output of this activity is architecture design document. And this way shows you or establish the steps, activities, and outputs, what you have to do, and it gives your clear understanding that you are doing your product well and in the right way, and with right and all the activities which is needed according to the standards, and according to your experience and your intuition and feeling of quality is there, and it corresponds to the standard. So how it is described here, we have to describe activities like a V model, it's called, and the left part of the model is project development or design and development. On the bottom side is integration, how to integrate all the parts together, and the right side is how you verify and validate your product. And you can see here the first step is planning, and the response in the planning is assessment. After planning, we can start specifying safety requirement specification. Based on the requirement specification, we are going into architecture design. Based on architecture design, we are doing detailed design. Taking all these artifacts, we can create integration and try to, and verify your part of detailed design, make integration testing based on architecture design, and validate the system based on requirement specification. And of course, make an assessment providing all the items which are produced during execution your project. Okay, let's a little bit look in more detail in the first stage of planning stage here. Functional safety management plan and configuration management plan is start point documents. In addition to this document or documents, you also need to create personnel plan, doing how you evaluate your suppliers, distributors, to be sure that quality of input goods for your product is okay. Also, you need to establish a field failure report procedure. It is how to process failure from the field or from test or whatever. Change notification procedure, how to notify users that you have changes in the product, and changes not necessary that you find bugs. For instance, some component could be obsolete at specifically if it is key component like MCU or something critical for safety. It requires to notify and to run change request and change procedure of modification run here. But again, to start design stage, this too is enough to start process, and the process, it is something which is running in parallel. So in reality, we are establishing these two documents and running rest of them during execution the product, and when it is necessary, and defining when it is necessary. Okay, when we start a requirement specification, it is about we are considering our product like a black box, and here we need to define what product should do instead of how. So on the requirements level, we need to concentrate on the what we want to have in the product. I put some example, just very abstract, but nevertheless, the system shall transition to the safe state if a dangerous fault is detected. So on this level, this requirements is quite vague, because we don't know how many dangerous fault, what exactly is dangerous, because obviously we have no clue what can happen with our product, because we don't have a hardware, we don't have a design, we have nothing to do this. And when we are going into architecture design, here we want to answer the question how we want to make product working. And architecture design answers mostly on how we want to implement, but also some of the part of the requirements will also answer what we have to do. But we have to focus on how to do this. And here we can see that if sensor X signal is outside of the valid range, the system shall transition to the safe state. So here we know that we have some sensor, and if it outside of the valid range, we have to go to the safe state. And on the detailed design, we have to specify more hardware related or software related and design specific behavior on the signal range, like delays or whatever you need. Some specify the real range of the signal in volts or in what is there. Okay, having architecture design and requirements in the architecture design, it allows us to make verification more systematic, because on the one hand we have requirements and we have to make a verification of these requirements doing integration testing, like injection of and this case can say, okay, just inject some signal which is outside of the range and confirm that particular these requirements works. And when we are going to the validation of the system, now we are on this stage, most likely all of the tests are done, and our work here is to confirm that all defined dangerous faults are tested. So on the integration level, we are more thinking about some functions, and that we are implemented our design in accordance with architecture design, so that this piece of hardware with software works as expected, as designed. But validation answers the question that the product makes it works as it is expected and covers the need of the product and the purpose of the product. Yeah. And if we're talking about validation here, we are trying to check that all the requirements are covered, are checked, and we have test cases and so on. Okay, having architecture design, requirement specification, architecture design, we are developing detailed design for hardware, for software, and after this one, we have to integrate all the parts together. Integration, this is a process where we integrate software with software, hardware with software, hardware with hardware, hardware with mechanics, and whatever. If you have if you system subsystems in a system, and to the level to create a product which serve for functional safety. And deliverables on this stage is detailed design, and also if we're talking about software based on detailed design, we are making unit test planning, and having code, we execute these test cases, and we have unit test reports, and so on. Okay, here is if we run all of this model, and we when we execute the entire functional safety management plan activities, on the output, or we can get from this document, we can extract documents which we have to develop during life cycle or during execution the project. And it is more than 30 documents. Even it can be more if we depend on how we calculate them. But this is example of documents package which we have to provide for assessor, or we have to create during development of the product. Okay, and now we are moving to and this is functional safety management plan is finished with again, just remind to you, it is inputs, list of activities or action activities, and outputs of each activity. And if we collect all the outputs, we can create a list of our items or documents we have to produce. And here we are have to consider how to store this data, and to understand how to store, how to structure, how to make the structure for this data. The configuration management plan enters, and it needs to establish first of all the structure of your library for the project, how to store the data, and identify all the configuration item. Configuration item means any artifact you need to store and you develop during life cycle. It could be source code, any binary files, schematics, mechanical drawings, any test plans, test reports, review reports, whatever, everything which is needed to make a product. Even development tools also is a part of configuration item, and they are under configuration management. So this is you are creating a structure, and now if you start development, you understand, and people who read this document and understand where you can find this item, that item, how to store, where to place this. Having a list, you have to a scope for your project. So then the next step of developing a configuration management plan is creating a map of dependency between documents. So if you have a list of documents and looking into your functional safety management plan, what is input, what is output for each activities, we can create a map for your documents. And here we have functional safety management plan, and inputs can be some external, like a risk assessment if you have this. So you have some external inputs for this one. So if you are developing like a standalone a gas detector or pressure sensor, you can define these requirements or risk assessment depending on the application standard. So, and it could be input for your safety requirement specification. But now, just to limit scope, I want to to more concentrate about and start from a functional safety management plan and safety requirement specification, just to have this focus on development of the product. Yeah, and establishing functional safety management plan, and it covers some extra documents, configuration management plan. We are starting development safety requirement specification, and this point where the real the product design starts from safety requirement specification. This is the place where we are first time thinking about our product, what it should do, and what the requirements should be for the product. And inputs for this one, it is standards or risk assessment and product requirements and common sense. Just we are creating a requirement specification. Based on requirement specification, we create architecture design. During architecture design, failure mode and effects analysis we are doing. And if you have hardware package, we can do failure mode, effect and diagnostic analysis. So this is kind of covering what the effects and taking into account what the diagnostic is. We discussed how to convert dangerous faults to safe faults. Taking into account, we get some numbers of probability of failure and these numbers needed for to prove that you are, of course, that you meet the requirements of your level of safety integrity level. Based on architecture design, we are stepping in software architecture design. Based on architecture design, we are doing software detail design. Taking all of these documents, we are going into coding, creating code standard document, and based on software detail design, we can get unit test plan, and here is a verification and validation part of the process. So integration testing is based on requirements or statements from architecture design and software architecture design, and as a result, we are getting integration test report. And safety requirement specification is an input for a validation test plan and for a validation test report. Yeah. Okay. Now the idea is to have a dependency between documents, and having them, we can put them into milestones or baselines, how we want to make a release of this one. And now we are switching to baselines, and logically we can collect the data like called baseline safety case, and it is what we are going to the assessor like a start point. And we recommend here to go with configuration management plan and functional safety management plan to demonstrate that you understand what functional safety is, and to get some feedback that we are on the right way and everything is okay, or what we have to improve, or something like this one. And baseline here, it is a set of all documents or that you produce here and that are under configuration management. So if we're talking about this stage, only 2 documents, let's assume only 2 will be in our baseline. And here we have to assign a version for them, a unique number, store them, and say, okay, this is the first release which we sent to assessor. And if we need to change them later on, we have to increase the version, put revision history, and at the end we have to roll back to any version of the documents we have. So it is the first baseline. The next baseline is requirements specification. So here we have previous documents and store also requirements in addition, and we have wider baseline. And over the lifetime, we are increasing or just fulfilling our repository and put items there, and all the time, all the changes of this library is configuration item and audit. Yeah, and also important thing is to plan configuration audits. if you split in some steps, in some activities, and we are to confirm that we are fulfill all the items we have to produce during this to this milestone. We have to store them and formally create a checklist or whatever, just peg that, okay, this version in this milestone, this is the part of this audit, and is a place, everything is reviewed, finalized, so there is no comments and everything is okay, and move forward. Also, it is sometimes in companies called like a gate models, like a gate. You have to prepare everything to gate to go to the next stage. So it serves for this purpose. Okay. Yeah, and to simplify life, we are using it is not only for functional safety, but to make this configuration control and audits, we are usually using or Git or SVN or any tracking system. Also, you have to we track changes. If we are working with bugs, we are creating, we are using issue trackers to store them, to put bugs, to follow them, to fix them, to go status, to validate, and to make it traceable, and all findings are recorded and can be tracked back, can be analyzed if something happened, and make your transparency or traceability of the product in place. Okay, one of the important thing is to tool identification and their control. If we are working with specifically with software, compiler and IDE, it is very important things here, and we have to establish what tools we are using. Also, we have to record what the version we are using. We have to define the procedure. For instance, if you have a version or compiler version 1, and if you want to move to version 2, so you have to specify the actions, how to validate or how to check or evaluate that this new compiler is okay, is not, and it will not damage your product and will not compromise your safety. So it is not something very difficult. You don't need to validate or to make a verification of the tool compiler, but you have to place you have to have the list of actions in place, the procedure how you do this. So usually it is, you are compile the code and see that main functionality that it works, so there is no lags, and it runs 1-2 days without issue. I mean, the code compiled with new compiler and everything is okay. But you have to address this, and you have to have plan of action how to do this. So it is why it is important. And the same for any tools, even you are changing issue tracker or whatever, you have to consider what will happen if you change this. Is it critical or not, and how to do this. Okay, here the most important, or one of the important thing, it is how to control your modification. And we know that now in modern life we are getting updates for apps in your phone every day. Some apps are updating, and it is a normal thing here. But in functional safety, this process is quite heavy, because you have to consider how critical the changes is. What is impact of the change? Is it issue in requirement specification, or it is architectural level, or it is some simple thing into UI or whatever you want to do. And during this process, we need to assess how critical the change is, and identify how much validation and verification we have to do before releasing. So if this is a trivial thing, maybe it is only enough to make integration testing. But if you are changing hardware, we have to consider: do you need EMC tests or some type testing, and depending on the change level, the scope of changes will be defined. And the idea is here to create a procedure how you are doing this, who is needed to do this modification, how to assess the criticality of change, and how to store the changes, and how to notify end users about this issue which is found. And obviously not all the issues or bugs can be fixed immediately, and maybe you will need to replace or to update your product in 1 year when it will be possible to replace this. And you have to bring this information to your client or to the user and explain how to do this, what is the criticality, how to avoid, maybe just be more careful, or just understanding how to do this. Yeah, and it is how it is work. Yeah, and just to summarize what we are looked here, we are starting from functional safety management plan, configuration management plan, and developing process documents during execution. So we are suggesting this strategy. Running the product through the way model, which is described in functional safety management plan. Put all documents in place, create a map of connections between documents, and understand what the sequence, what the roadmap of your product in configuration management plan, and make the product real. And here you need to consider how much competence you need in your project, and who should do this. And obviously having this different type of documents, like a planning, like a management documents, and we are sometimes get a request, please give us software developer who can do a functional safety product. And unfortunately it doesn't work in this way, and you need more roles, and also you have to put some independency in your project. For instance, if you have one person who developing a code, obviously someone else should do at least planning of verification this code. So this is for the project, for the process, what I want to describe. And now I am pass the floor to Alexander to go forward with, have an access.
Yeah. Thank you, Vadim. Basically, what I want to conclude this presentation with is actually the product and project roles you need to have in the functional safety projects. Basically, first of all, you need to establish correct leadership. So you need some people who can make decisions, who can actually defend the decisions you have made during the process. And those decisions, those leadership roles that you will have in the team, they will help you to actually go smoothly through the process and actually bring you to the compliance without any major blow-ups on the way. And the leadership roles in the typical functional safety project would be a product manager who will actually connect product goals with safety objectives. It's actually a little bit cumbersome sometimes to explain to the product people, to the regular product people coming from the sales department, why the hell we need some complications that are required by the functionally safe product. Then this role normally codefines system architecture and safety requirements, ensures that the complete documentation is in place, and also the life cycle that is defined in the functional safety management plan is followed. And then we have, and then reviews apparently the test planning. That is fine. Then we have the classical project management role. That is also important, that we actually do the project, not only concentrate on functional safety, but ensure that the functional, I would say, just functional product appears at some point. So it's really important that one thing is to follow the process and have fun with functional safety. Another thing is to actually bring project to the market. And then we have a functional safety architect or coordinator, and this is the person who actually kind of does some planning and the floor activities like checking in detail, checking the documentation, supporting that processes, all the processes are oiled properly, so they are working in the team and stuff like that. So, but that's only about kind of lead roles. And to be able those lead roles to actually produce any single line of code or any single track of the PCB, we obviously need engineering team to back them up. And the engineering team here is, of course, consists of architectural roles here on the right, hardware and software architect, and also the developers, more regular developer people, and then quality assurance and quality control people who can actually drive the process to be or validate the project and the product is good enough. So that's what you need to address in terms of roles. And what is important to say is that in your personal plan, you need to describe who does what are different roles are addressing, and you shall not necessarily have like one dedicated person for each role. You can mix that up. You can have one person doing several roles, but then you need to put a justification in the document why you believe it's good. So it's too late if the assessor comes in and then you say, oh, but by the way, there is only Mr. Joan who did everything from requirements to actually, the pre-compliance checking. That wouldn't fly. But if you have the personal plan that is, well described and have a good justification saying why would you be able to actually address the requirements by fewer amount or the smaller amount of people than the roles are described, then it's fully fine. And like Vadim said, you need to ensure that there is, according to the V model, there shall be part of the team that works with the left wing and the part of the team that works with the right wing. So you don't have people developing the code and then checking their code that it's all fine. That one will be hard to justify. I'm telling you. So that's about the roles. And what I want before we conduct and conclude the webinar and move to questions, if any, what I want to say is that it looks overwhelming. I got that. So all the artifacts we demonstrated in one of the slides, someone will say, well, we will never do that. And yes, unfortunately, the very first functional safety project in the organizations normally creates a major organizational ripple. Major ripple. Why it happens? Because it's really hard to convince regular development people that functional safety is that complicated. People think it's more like bluffing, like okay, we can do it simpler. So what you need to do, you need to be calm. You need to create these organizational assets. So the process that you described is partially, I would say, the bigger part of it is organizational assets. So once you have done those processes for very first project, then you can reuse. And the complexity of those process creation is comparable to the development project size. So let's say you have no process, you just need to develop the thing. You have to develop some kind of device. So the development of that device can be easily comparable, and for simpler devices, smaller, the development effort will be smaller than the processes creation around it. But you have to do it once. And for many who are first time to the functional safety, this is actually a biggest mental and also financial blocker. How to actually get into those projects, because people don't believe that it can be that difficult. And for this, apparently, you can ask for us in Actos development for help. So we can first of all guide you through the process. We can guide you through some of the typical do's and don'ts. In creating those processes, we also do have some templates for processes. However, some of the processes are tailored towards specific customers, so they are obviously under NDA, but we can easily help you in this complex task and sparring between how to actually make this functional safety project. So that's why we can streamline, we can help you to actually go through this process creation hurdle. So that's what we can do, and apparently anything else what you can face as a troublesome situation during the process of making the product, we can be there. We can be a strong shoulder for your engineering and process team. So that's I think all for today. I'm very happy having all you here, and thank you, Vadim, for the great presentation. I think we have time for questions, if any. So I'll be happy to answer your questions. Either you can unmute yourself and ask the question, or you can just type the question in the chat box. Let me just find the chat box here. Well, there is one. Yeah, so there is a question from Dmytro Romanenko. What is the minimum number of employees required for a typical project? What would you say, Vadim? Typical uh, minimum number for a typical project. What that could be?
Okay, it's a very good question. Just let's count. So we have at least one functional safety expert who can bring these ideas and check that everything is in place. Have at least project manager, like a one person, and hardware and software developer, let's say with high seniority. So I think at least if you have hardware and software in place, at least 4 person, and maybe one QA, but it can, yeah, and one QA at least, 5 person team, but it is absolute minimum.
Okay. So we need hardware expert, software expert with architectural seniority. Then we have
Yep.
functional architect or functional expert. What a functional safety expert? What would you say, Vadim?
Yeah, and product or project manager, at least one person to combine these two
Okay.
roles. And
And then we have someone with the buggy whip to control that everything is done in a correct manner, right? So that means quality assurance and control person.
yeah, at least one person who can, and also you will need later on, for if we are talking about team, but anyway, later on you will need to do type testing and external laboratory, to do EMC or climatic tests, whatever you need, but we are talking about the core team.
Okay. So that's the question from the chat. Any more questions from anyone?
Yeah, it takes time to type a question. Maybe someone typing is a big one.
It's a typical Schrodinger's cat problem, you know, if someone is typing or not. Niels is asking about where can he get an access to the slides and or recording a webinar. Well, basically, right after the webinar, you get the feedback form, which you have to fill to make us better for next webinars. And then if you fill the form, then you will get the link, the deep link, both for the video stream and for the presentation itself. So that's the way to get it. And I can see that that our marketing team has already sent the feedback form link. There is another one, Vadim, for you. How do you manage from Mats? How do you manage the safety verification of an existing product that has been developed without these processes, but is facing future safety requirements and safety verifications?
Okay, it is also a very good question. 61548 or other safety standards has they have a term which called proven in use. So if you have a product which is used very long time and it is reliable enough, you can say that it is safe. But there is a very big problem. because to prove this, you have to to prove this, you have to establish field failure procedure to get statistical data of reliability from field. So you have to produce a lot of units. You have to have established procedure for getting faults, analyzing them, and to calculate the fraction of dangerous undetected fault in your product, and and their frequency of this fault, occurrence of this fault. And afterwards, you can say, okay, this is proven use. But the problem is, if you make a changes, you have to again wait 1, 2 years, whatever, to get statistical data. And to be honest, I have never seen this approach implemented in fact, because if you have a product, you all the time permanently changing this, doing some improvements, some features. For sure, you don't have a separation between safe or non-interfering and safety function is not separated. And when you are changing, you have to all the time start getting data from the field. But if you have a working product, it can be a very good basement for creating a functional safety product. And here, what we have to do, usually what we're doing, we are looking in existing product, try to understand what is the really the safety function here should be. And unfortunately, we have to design this from the beginning. Of course, based on the software you have, if it is possible, on the hardware you have, if it is, or as much we are using as much as possible. But again, if you are not following the process, if you are not doing the right architecture design, in practice, it is very low fraction of reuse. Because
So basically, there are two ways to do it. Just to answer Matt's question directly. One is to, if you have very detailed field failure analysis reports, let's say you have produced 100,000 units, no changes. You have all the historical data about failures and analysis and stuff like that. You can go with the way of proven in use justification. You can go to the certification body and say, well, we have so many products, they have been running nicely, they were only this fraction of errors, and we can justify that those never led to any hazardous situations. So that will be one way. Another way would be to kind of do all over again, not necessarily developing everything from scratch, but at least we need to start generating all the process artifacts. We need to start doing the architectural design. We need to calculate all the required, diagnostic coverage, things, generate, FMEA and stuff like that. And only then we can start applying, so to say, this already existing product to be compliant with newly introduced safety requirements. So these are the two ways to go, basically. There is no shortcut. Even if some consulting company offers you, the easy way of recertifying your product or getting it compliant with the modern requirements, you better stop believing them, because it's a very well known fallacy, but unfortunately it doesn't bring you to the safe shore with your product. So that's what we can say.
Yeah, and also if your product is very easy or simple, like like a relay or something very kind of stupid simple, it could be proved without some. But if I'm talking about software and yeah, specifically software, no way to avoid if you want to modify this.
Well, there is one more question. I think we can easily answer it, Vadim. Ilya asks about bug tracking system as a requirement for functional safety projects, like the existing of the bug tracking system that can apparently allow you to traceably do management of your product. And then the question is, if is CI/CD, specifically CI, a mandatory requirement? If so, how should it be structured to accelerate development? So CI is continuous integration and CD is continuous deployment. Just or delivery. That just to remind the team here.
Yeah, because in my presentation, CI could be a configuration item also.
Okay. So, but what is the answer here, Vadim?
Okay, standard does not have direct requirements to have CI/CD. It is how you specify this in your configuration management plan. So if you have a good procedure how to do this manually with enough manual check, you are welcome. But CI, specifically CI here is make the product. I would say it simplifies your integration or product. It is only for this purpose. So this is not mandatory, but it is mandatory because if you do this manually, it will take it will take so much time that you will be not competitive on the market. So I would say this is market demands to have this.
So in other words, the continuous integration tool is not mandatory requirement, but it simplifies your life, and it allows you to be more effective.
Yeah, just imagine you need to take a procedure how the person should run this integration. You know what the compiler, what the configuration should be there on any PC. What you have to do, or how to test, how to store this, and how to run static code analysis, unit tests, and so on, so on, so on. It's just only a lot of work. But if you think that you will compile this not so frequently, uh, it could be a way to avoid this. But again, in modern life, at least if you need to change once per year, and specifically if you are executing the project and you are uh, every day releasing something new feature and adding, it is better to have this. You just save time. So it is about saving money, not
Okay.
about yeah.
Got it. Thanks a lot, Vadim. I think that's all the questions, and we are running 1 minute out of our timeline. So thanks everyone again for joining our webinar. Please fill the feedback form and subscribe for our next webinar that will be more practical about tools, tricks, and tips, how to use different tools, and apparently addressing the CI/CD question as well. So thanks everyone. Have a very nice evening to all of you, and we are looking forward to meet you again. Bye bye.
Bye.
Thank you.